The business leader. Now that our visualization specialist has created our dashboards, they're ready for our business users to consume. Business leaders are the main audience of business intelligence reports and dashboards. They are also key to guiding our data and analysis strategy. The main role of business leaders is to make decisions that either maintain or change a course of action. But there's one other role that business leaders must play to help the BI team work effectively. Leaders must prioritize communication with their BI team, asking questions that highlight the priorities of the business. Questions should engage thought and should, where possible, avoid being transactional. What does that mean? Let's look at an example. A bad example of a question is, could you run the sales and inventory report for me for September? That tells the BI team nothing about why the question is being asked or what is important to that business leader. A better example of a question might be, our warehousing costs are too high. I need to understand which products have the lowest turnover rate. Now the BI team really understand the priorities of the business and can make a better decision as to which data is going to answer that question most effectively. So only by being transparent about business goals and priorities can the BI team really deliver meaningful reports that guide the business in the right way. In all this discussion of business intelligence, transforming and analyzing data, there's one thing we haven't discussed. Where is the data stored in the first place? How did it get there? And who manages that process? This is where data engineers come in. Data engineers source, organize, and move data between database systems. They can also be involved in decisions about data storage and infrastructure. The majority of a data engineer's job falls into the category of ETL. Instead of moving data between files and Excel workbooks, engineers focus on moving data between database systems. They automate this process as much as possible using what we call data feeds. The next task is to create data warehouses, which store all of the relevant data that the business might require. It's typically stored in a format that's optimized for analysis, and is beneficial because now all of the data we need can be found in one place. It's important that engineers develop an exceptional knowledge of the data systems they're working with. Engineers understand exactly how the data is structured, which helps them work with analysts to prevent issues down the line. Finally, engineers must look after data governance. This means ensuring the security of data as it passes between systems. Secondly, this means ensuring data integrity, for example, making sure that data is not duplicated. A key question that arises at this point is, why would we want to move data between systems in the first place? To answer that, we need to look at the types of database storage systems. At a basic level, we have two types of database systems. Some are optimized for transactional computing, whilst others are optimized for analysis by humans. At one end, we have what's known as an OLTP database, which is optimized for entering, modifying, deleting, and reading data. That's the type of database you'd be interacting with if you logged into your online banking. You want to enter transactions or see a list of your transactions. At the other end of the spectrum, we have a data warehouse, which combines data from multiple sources and is optimized for analysis. Instead of asking what my latest 10 transactions are, I now want to know by what percentage my monthly outgoings have increased compared to the same period last year. That's a very different kind of question. Now, where a data warehouse would typically contain all the information that a business would require, a data mart is simply a small data warehouse used for a specific project or team. The last type of storage you should know about is a data lake, which stores raw data in its original format. It can store both structured data, like tables and lists, as well as unstructured data, like emails and phone conversations. Let's take a quick look at the tools used by data engineers. I don't plan on talking about these tools in too much detail, but I want you to be able to recognize the names and roughly what they're used for. So firstly, engineers work with data storage, which could be in the form of a relational database or a NoSQL database. There are a few major suppliers of cloud services which also include data storage. These are Google Cloud Services, Microsoft Azure, and Amazon Web Services. Many of the next tools that we're going to discuss can be integrated into these platforms along with your data storage. We have three key coding languages, which are SQL, Python, and Scala. Now, big data has seen the volume and complexity of data increase exponentially. Tools like Hadoop, Spark, and Databricks help data engineers manage and move those masses of data. Finally, big data has also brought with it the possibility of live streaming data in real time. Tools like Kafka, PubSub, Kinesis, and Apache Beam help engineers manage these real-time data sources. As I said, don't worry about knowing the details of any of these tools. I just want you to be familiar with those terms when they pop up in conversation.